VFO sample to where we could use this as a VFO. So let me switch over to that. So this is pretty much the same, but what I've done is I've actually added things in here so that we could actually use the switch. So I've set up bands, and then I've set up the start and end frequencies for each one of the bands. Now these are in hertz instead of hundredths of a hertz. And then I keep track of the current frequency. So as we increment this, it'll change that frequency, and it should come back to us so that this remembers your frequency as you're jumping through bands. And then on button click, what it does is it says, okay, let's increment the band by 1. And then it checks to see if it's greater than the max. So if we went outside of the array, we want to go back to 0. And so that this way, when we actually get to 10 and we hit the button again, we want to go back to 160 meters. And then I'm just printing out serially the band change to whatever meters, and then the value. And then we set the boundaries for the new low end of the frequency and the high end of the frequency. And then we set the encoder value to the current frequency value. And then the only thing we really changed here is if it reads, then we're going to print out the value, and then we're going to set the current frequency to whatever that value is so that we can always keep track of what that frequency is. And then that's pretty much it. Everything else is pretty much the same, except that, again, here where we're setting the boundaries, we're using the low frequency and the high frequency, and then whatever the current frequency is. And then I've been playing around with this. I've disabled acceleration so that we can make single steps through it. And so I set the acceleration to 1. And then we're just going to go through the loop. So let me kick this off. And all right, let me reset it. Okay, so now let's go over to the serial monitor. And then I'm going to just start by, you can see I'm just basically changing the frequency by steps of 1. And no matter how fast I turn it, it stays steps of 1. So it's a very fine grain. Now what I'm going to do is I'm going to push the button here. And it says now we're at 160 meters. So now you'll notice that my frequency is now 1.8 megahertz. And then I can go back through this. We can play around with 80 meters. And all I'm doing is I'm just pushing the button in. Now we're on 20. Go to 15, we'll change it. And then we're back on 10, and you notice that it's at 49, which was 1 up from the last one we changed. If I go back up here, we were at 48. So it basically picked up with that. And so that's one way that we can actually keep track of what we're doing, or keep track of it while it's running. Now, this is not a way to remember your frequency when you shut it down and back up. There are ways to do that as well. We could actually write to the flash memory on the ESP32. Let's see, we got
How much flash memory is on the ESP32?
Well, I don't know. Let's go look.
I think it's 4 meg.
4. Okay.
Yeah. Well, let me go here to browser. Not. Let's see. It should tell us here. That's just headers. Well, yeah, I think you're right. Well, I know there's like, let's see here. Let me make this wide. It should tell us here. Okay, so there's, yeah, 448 ROM, and then you've got a static RAM of 520 kilobytes, and then 16 kilobytes in a real-time clock if it comes equipped with the real-time clock. Could have swore it was more than that though.